Welcome to Aerotech Solutions. So in continuation with our previous sessions, here we are talking about liquid crystal display interfacing. So this is one of the common interfacing with all microcontrollers. Whenever you are working with different peripherals with microcontrollers, so LCD is the common input output device with microcontrollers. So this LCD full form is liquid crystal display. So this LCD allows all the alphabets and numeric displays. So whenever your application demands alphabets, numerics with special characters, you can proceed with this LCD programming. So this LCD have some limitations, so which is not help us to display graphics and as well as pictures on the screens. So the previous displays, which are LEDs, 7 segments, so those have their limitations in terms of indications, and your 7 segment, which is allows only numerics like 0 to 9 numbers, and also hexadecimal characters A to F. So if you want to display more than that, you have to go for other displays like LCDs and LED matrix or dot matrix displays or graphical LCDs. So out of all those, you are talking about LCD screen here, which is liquid crystal display, and LCDs are available from the market in terms of matrix size M cross N. So LCDs are different sizes in the market, whereas 16 cross 1, 8 cross 1, 16 cross 2, 32 cross 2, 20 cross 4, these are the different sizes for LCDs. So these LCDs, whenever you want to program, you need to understand the hardware description about your LCD, and then you can start programming. So whereas the meaning of 8 cross 1 or 16 cross 2 or 32 cross 2 or 20 cross 4, which is very clear, which allows how many number of characters per screen. So your LCDs are available in different sizes and different shapes. There are square shape and rectangle shape, and depends on the demand or depends on the application purpose, you can choose whatever the size you are expecting. Whereas the meaning is very clear whenever you are taking or whenever you are dealing with 16 cross 2 LCD, so which has supports 2 lines, and one line allows 16 characters. So, and whenever you are looking for 16 cross 2, it totally allows 32 characters. This is the total capacity of your LCD whenever you are trying to display something on the screen. Whereas if you are dealing with this 20 cross 4, which allows 20 characters per line with 4 lines. So you can display 20 characters in the line, and total you can display 80 characters. So this is how, based on the size of LCD, you can go with different number of characters on the screen. So let's come to the physical description or pin diagram about your LCD. So, and LCDs follows the same pin configuration irrespective of sizes, and even your 8 cross 1 have same pins, and 20 cross 4 also have same pins, and 32 cross 2 also support same physical pins. So you need to understand the physical description, physical pins from your LCD. Let's see. So your 16 or 20 cross 4, whatever the size, it supports total 16 pins. Let's see the pin diagram. So let's see the pin description of your LCD screen. The first pin from LCD, which is ground pin, whereas the second pin, which is VCC. So LCD is working with 5 volts DC operating voltage. So whenever you want to deal with this LCD, you need to provide 5 volts DC source. The first 2 pins are the power supply pins for LCD, and whenever you are interfacing this LCD, just take care of these 2 connections. And the third pin, which is contrast pin. So from LCD, whenever you want to adjust the brightness of screen, you have to deal with this third pin, and this third pin is connected with variable resistor. And generally variable resistor have 3 leads. First pin is VCC and second pin is ground, and this variator pin you have to connect with third pin from the LCD screen. So once you change the resistance, it allows to adjust the brightness of the screen. Next, the 4 and 5 and 6. So these 3 pins which are called as control pins of LCD screen. The first one is register select, and read or write and enable pin. So whenever you are trying to work with this LCD, you have to take care of these three control pins, 4, 5, 6, and fourth pin working is very clear. Whenever you are trying to use this LCD for display purpose, so your LCD needs certain commands. So like deciding the position of your LCD screen, and you are expecting your text on first line or second line, or first line corner positions, or first line mid position, or second line corner positions. Wherever you want, you have to follow certain commands. And every LCD programmer, they have to understand these commands. And all commands are 1 byte size. So I'm just telling example here, which is 0x80. This is 1 byte hexadecimal value you need to pass to LCD screen to get your character on first line first position. So if you are expecting your LCD display with first line first position, you have to provide this command. Then, so what way I can send these commands from microcontroller to LCD? So you have the same data lines from 7 to 14, D0 to D7. From 7 to 14 are data lines. So using these 8 data lines, you have to pass it your command values or your regular text. So but whenever you are looking to send text to LCD, you have to make sure RS logic is 1. So this is you have to assign with microcontroller IO pin, and whenever you are trying to send commands, make sure you have to make sure RS logic is 0. So this is the logic you need to maintain for RS pin while sending commands through these data lines. You have to make sure RS logic is 0. If you are trying to send text to LCD, take care of RS logic as 1. So this logic you need to maintain with the help of IO line. So this RS is connected with IO pin from microcontroller. While sending text, keep your RS logic as 1, and while sending commands, keep RS logic as 0. So there are other commands like scrolling the display or moving your display to right or left and changing the line of your LCD screen. Everything depends on the commands only. Okay, so your LCD not allowed to write text directly, so until unless without passing these commands. So take care of these commands, but while passing commands, keep RS logic 0. While passing text, keep RS logic 1. This is the working of RS pin from the LCD. The next pin, RW. So this pin talks about whether you are doing read operation or write operation. Make sure whenever you are sending write from microcontroller to LCD, keep this logic as 0, and to read data, make sure logic is 1. This is the working of RW pin. And the sixth one, enable. So this enable, which will keep making LCD for every change of data, your enable should be high to low once with certain delay. So every time for every change of data, enable pin should be high to low. So even for commands, even for text. Suppose you pass the first command, you are looking to send next command, make sure enable pin high to low, which is also connected with microcontroller IO pin. So this is the 3 control pins working, RS, RW, enable. So RS working is very clear. While passing commands, keep 0, and while passing text, keep logic 1. And RW pin working is to write the data from controller to LCD, this is logic 0, and to read data from LCD to microcontroller, this RW logic is 1. And make sure enable pin for every change of data, enable pin high to low once. And the 7 to 14 are the data lines of your LCD screen. So using these data lines, you need to send text or you need to send commands. And any character you are looking, anyway, you know all the characters are 1 byte size. And the last 2 pins, 15 and 16 pins. So these are backlight VCC and backlight ground. So whenever you are trying to turn on the backlight of your LCD screen, so provide 15 pin to power supply VCC and 16 pin to ground, so that you can watch the text on dark places. So without having any internal things. So this is the complete 16-pin configuration from LCD screen. The first 2 pins are power supply, and third pin helps to adjust the brightness, and 4, 5, 6 are the 3 control pins which allows to pass commands or text, and 7 to 14 are data lines, and 15, 16 pins are backlight pins. So if you want to interface this LCD with any controller like Arduino or 8051 or PIC microcontroller or any 32-bit controllers, you have to remember this pin description. Thanks for watching.